Hey guys, it's Karim. Today I'm going to be lecturing on protocol architecture in computer networking. In this lecture, I will be focusing on what a protocol and protocol layering actually is, and I will also tell you why protocol layering is important in networking. In computer networking, a protocol defines the rules that both the sender, receiver, and all intermediate devices need to follow to be able to communicate effectively. Um, so protocol is sets of rules that govern data communication, which actually defines what's communicated, how it's communicated, and why it's communicated. The type of protocol used may be different according to the complexity of the communication. That means when communication is simple, we may need a simple protocol. For example, if two persons are actually talking face to face, then the task involved in the communication between the two persons is just talking and listening. While one is talking, the other will be listening, right? So there is no need to decompose this task into layers. So this type of communication is a simple communication and needs a simple protocol or a single layer protocol. But for complex communication, we may need to divide the task between different layers. For example, when two friends living in different corners of the world want to share a confidential project, let's say by email, then this will just take different steps, or it will just involve different tasks, right? There is preparation of the plain text or the project, then that should be encrypted into ciphertext because it's a confidential project, and finally sending, right? There are different tasks, so these tasks will be involved in different layers. That's why this communication between two friends in two different places will be decomposed into at least three layers, right? At least three layers. As a principle of protocol layering, both layers need to perform opposite tasks. As you can see from the figure, there is a plain text right here, and there is encryption, decryption at this layer or layer 2, and sending and receiving at layer 1, right? While one is sending, the other will be receiving. While one is encrypting, the other will be decrypting, and so on. So both layers need to perform opposite tasks. And the second one, the objects under each layer as the two sides should be identical, because the objects under layer 2, for example, is the ciphertext. So while encrypting and decrypting, the ciphertext is actually the ultimate goal in layer 2, and in layer 1 it will be the mail. That's actually the object under this layer, and in layer 3 you can see that it's just the plain text. So it's the objects under each layer should be identical. So when the communication is complex, we employ protocol layering. Protocol layering enables us to divide a complex task into several smaller and simpler tasks. This layering is best illustrated by an example in our daily life. If we consider two friends who communicate through postal mail, we have a sender, a receiver, and a carrier that transports the letter, and there is a hierarchy of tasks. At the sender side, here at the higher layer, the sender writes the letter, inserts it in an envelope, writes the sender and receiver addresses, and finally drops the letter in a mailbox. Then in the middle layer, you can see that the letter is picked up by a carrier and delivered to a post office. Finally, at the lower layer, the letter is sorted at the post office and transported by a carrier. On the way to the recipient's post office, it may be transported by truck, train, airplane, boat, or a combination of this, or any kind of transportation available. Then at the receiver side, as a lower layer, the carrier transports the letter to the post office, which then at the middle layer is sorted and delivered to the recipient's mailbox. Finally, at the higher layer, the receiver picks up the letter and reads it. So from this example, we can see that there is a hierarchy that breaks down communication tasks into manageable subtasks, and defines their interrelationships. And it's important that each layer provide a service to the layer above, because this is actually the ultimate goal of protocol layering. So with the proper hierarchy and service, a well-constructed layered model enables complex systems to be specified, designed, and implemented. Generally, there are two main advantages of protocol layering. The first one is modular design. In computer engineering, we know that modularity is important to solve bigger problems by breaking them into smaller ones, because by solving the smaller problems, we solve the bigger problem. And the second one is easy to troubleshoot, because if a communication is decomposed into different layers, like 5 layers or 6 layers, then if a problem happens, we can actually check each layer one by one, and we can easily find the problem, right? So it's easy to troubleshoot. So thank you very much for watching, and if you have any questions and comments, let me know in the comment section below.